So who are you? And thanks for inviting me out to see your lab.
It's a pleasure. I'm Roy Levin. I'm the director of Microsoft Research in Silicon Valley. And
That's where all the cool stuff happens, isn't it?
It certainly is. It's a delight to be here.
I'm sure the Chinese lab would disagree with that, right?
Well, I think they have a good time, and I think they enjoy visiting us as well.
Yeah. Tell me, for people who don't know what Microsoft does here in the Valley, because people think of Microsoft and think of Redmond, Washington.
Of course, yeah.
Some company up where Starbucks is and Boeing, but not down here in the Valley, right? Tell me a little bit about what happens here in the Valley.
Microsoft has a major development center here in the Valley, and the campus in Mountain View has close to 2,000 people that work for Microsoft, and there's another several hundred elsewhere in the Bay Area. Yeah. The lab that I manage is part of that campus. We're a small part of it. There are about 50 of us. But the businesses that are housed here on the campus, probably a dozen different parts of Microsoft, from parts of Windows, Xbox, our TV business, parts of the Macintosh Office business, and so on.
Tell me about some of the expertise that you can only find here in the Valley, or is a lot easier to find here in the Valley than other places in the world.
Well, I think that what you find in the Valley is people have experience working in a variety of different companies, because there are so many companies coming and going here all the time. So technical expertise you can find in various fields all around the world. I don't think that we have any corner on any particular technical field. But I do think that what people have in Silicon Valley that is unique is this enormous opportunity to try out things in different companies and to learn from those experiences. And we have a lot of those people on this campus.
Tell me a little bit about what your 50 people are doing. If I walked around the lab with you, what would I be seeing? What kinds of work is being done here? Because I know I got a tour. We got a tour with our cameras up in Redmond. So.
Right.
But tell me a little bit about what's going on here that's different than what's up in Redmond.
Well, the difference, first of all, is that we're a lot smaller. The Redmond lab is many times our size. And what we choose to do here is to focus in a particular technical area, whereas the Redmond lab, and indeed most of the other labs, cover a quite broad spectrum of computer science. Our focus is distributed computing, and so we do work in the subspecialties that really relate to that. For example, security, privacy. We do work in web search. We do work in computing system architecture, distributed systems, and a number of other areas.
I have a sense of what you could do with a distributed system. It's sort of like when I visited CERN, they're using a distributed computing system to, filter the data coming off of all those sensors, because
Yes.
they have sensors that are bringing gigabytes per second of data, and they need to be filtered and then sent to labs around the world where different experiments are done on them. But tell me a little bit about what distributed computing is for you.
Well, I think in the corporate setting there are some parallels to that. If you're operating large services, by which I mean things like Hotmail or Live.com, what you have is a large collection of servers in a data center or in multiple data centers that are collectively providing that service. That's a complicated activity. That is a distributed system. And there are many technologies that go into making that distributed system work, some of which are quite mature, some of which are quite immature. And a lot of the research work that we do is focused on making that kind of work, I wouldn't say more routine, but more, shall we say, professional, reduce it to engineering practice.
Interesting. I've asked a lot of companies, even when I worked at Microsoft, I wanted to get into the data center and get a tour and see what a data center was like inside, and very few companies let you do that. What is the secret sauce? What is the bleeding edge stuff that I would learn if I got access to a data center? Because my friends work on Hotmail just a few doors down here, and they haven't even seen their data center. They build Hotmail, and they haven't even been into the data center to see the machines that their code runs on.
Right. So I think what's going on, certainly in terms of the security in those places, is just sort of generic security. It's not that you're actually going to learn some deep, dark IT secret by being in a data center. Most data centers from the outside look pretty much the same. Big building full of racks of computers, lots of cooling, lots of power. The interesting things, of course, are the architectural stuff in terms of the way the system is put together, the stuff that you don't actually see when you're in there. And I think that this is an area that is actually ripe for a lot of research. And that can cover a large number of levels of abstraction, really, within the system. There is certainly interesting research to be done at the networking level. How do you actually interconnect the machines in a data center to achieve robustness and high performance and all those good properties that you want to have in there. Above that level, questions of how you actually manage the servers to balance load among the different clients of the service, or indeed across services. The data center may support a variety of services. So how do you decide which computers go to which thing today, or this hour, or whatever it is? So that's a kind of a resource allocation issue. And then above that level, you look inside a particular service and you say, how does my data get decomposed? Where do I put it in order to understand how the application is going to perform, or to make it perform better? I might want to change that. I might want to change it dynamically. Hotmail is an example you mentioned. Lots and lots of user data. And of course, new data coming along all the time, new users coming along all the time, new machines coming along all the time. How do you actually provision all of that to keep it running well? So there are just a huge number of issues. I just mentioned a few, and how you make the data center actually respond to the needs of the business.
Yeah, I remember talking to one new hire up in Redmond who said he came to Microsoft Research because of the data set that he could use. Because services like Hotmail have 300 million people on them in just the last month, right? Or I don't know, 200, 300 million. I don't know the numbers. You probably know the numbers better than I do.
Hundreds of millions of people.
It's a big data set that he can then do research against, right? And there's very few companies in the world that have that size of data set to play with.
That's absolutely true.
So what kinds of things can you study, in a data set like that? What kind of things?
Let me give you an example, not from Hotmail, but from the web search area.
Yeah.
A search engine like Live.com records the queries that are placed against it. So you get this massive amount of data, all the queries that people have issued, and information about what responses came back. And you want to be able to study that information in order to give better responses, more relevant responses that make the search more compelling.
Yep.
So how you study that large collection of data is a matter for research itself. Yep. Managing the data, getting it out of there, and being able to work on it. So there's really two aspects to what the person that you spoke to was saying. One is having the data set itself, and then having the tools and the infrastructure necessary to deal with those large numbers of data elements.
Yeah, and tell me a little bit about some of the stuff that you guys are learning. What are you seeing from that data? It's particularly, let's just take search. I remember talking to people who were doing eye track research on search engines at Microsoft and learning about how people look at the search pages, and they knew that very few people clicked advanced search, for instance, or very few people clicked next page. But that was 3 years ago, so I'm sure you've learned some more since then. What are you learning in the labs about how humans want to, get access to these large data stores?
So I think I'm not personally in the area of web search, so I can't really give you a detailed answer to that. But I think if you reflect on your own experience searching the web, you know that there are lots of times when what you really want is the answer to a question. Yeah. And you really like to just type a question into the search engine and get a sensible answer. Yeah. And instead, what the search engine is really good at is giving you facts, okay? But that's not the same thing as an answer in many cases. Yeah. So I think one of the things that we know about search is that we want to, in some sense, up-level the answers to something more than just here's a pile of web pages that seem to be related to what you asked, have a nice day. What you really want to do is to be able to answer the question at the level that the user posed it. And in mining this low-level stuff, to see the kinds of questions that people ask, that gives us at least some insight into how to attack that problem. What the questions are, the structure of the questions that you want to be able to answer.
Yeah. If you go to MicrosoftLive.com and type what's the address of Microsoft's research center in Silicon Valley, you'll probably get a page back, right? Which doesn't have that answer. You might have to click 4 or 5 more times around that page to find the answer you were looking for.
That's certainly true. That's a good example of something where it's a particular fact that's likely to be on the page, and that would probably be one that would be relatively easy to answer. But if you come to a different kind of a question, more like a why type question, rather than a what type question, then it's going to be a lot harder to find that, unless there happens to be a Wikipedia entry on exactly that, and then you're in business, right? So, why is the sky blue? Well, there probably is a Wikipedia entry on that. But a few years ago there wasn't, and somebody created that because people who asked why is the sky blue didn't get very good answers from the search answer.
Yeah. Since you're in a unique place in the world where there are so many companies around here, does that change the ability or your research vision? Are you working with other companies more than other research labs at Microsoft, or to partner on different projects? Because so much, I mean, Marvel's here, right? So the latest movie was developed, 5 miles away, right? And that certainly gives you access to a different set of potential opportunities than you would have if you worked in Redmond or worked in China or worked in India.
Yes, and I think that we collaborate very extensively with universities, and part of the reason for the lab being here in Silicon Valley is that we have excellent universities nearby. They're not just a source of talent, but they're a source of collaborators, and that's very important to us. The same is true in Beijing. The same is true in Cambridge, England. I mean, they're actually embedded in the university there.
Yep, I visited
you've
that
been
lab.
there, so you know that it's literally on the university grounds.
It's right across the street.
That's right. That's right. So that's a very important aspect of the way we collaborate. Collaborating with other companies tends to be a little bit more difficult. Intellectual property issues can get in the way there in a way that they don't tend to get in the way with universities. So we don't do as much of that. But there certainly are examples where we've collaborated. And in fact, people in my group have collaborated with folks in HP labs to do some algorithmic analysis work to essentially discover best case solutions for best case algorithms for a certain class of dynamic graph problem. And there it was important to be able to share the same kinds of data and to share the algorithms so that you could get a apples to apples comparison, and that was an area where we were able to collaborate. So it certainly does happen, but as I say, it's less frequent than with the universities.
Very cool. Well, thank you so much for a fun little look. And
It was a
is there
pleasure.
anything else you want to tell me about your research lab or what's going on here in Silicon Valley? Because you got people all over the world watching.
Well, I think the main thing is that we're always delighted to have people come to visit us, and I hope that when people do come to visit Silicon Valley, they'll stop by the lab and find out what we're about.
It's a very interesting visit, so thank you
Good,
very much.
thank you. My pleasure.